why'd you spend $500 for rocker and you didn't get rollers? What kind of a deal is this? Why'd you spend all that money for S&S crap? Waste of money. Alright. So these are what? 4170 is the stock valve, I think. You want those bigger valves like I bought for you?
Yep.
900?
Yeah, those are the ones.
Versus the stock ones. See how I grind a stock valve? It looks like a racing valve. See? That's a 3-angle valve job. 3 angles. They talk about the valve or the whole job? Alright, so you had these nicely powder coated. And then you dropped the ball and didn't clean the inside of the heads out.
Yeah, they failed to blast them. As per request.
Great. Good job. Okay, what am I doing on these things? Making them go fast?
Go fast.
Go fast. I got my finger dirty. I ain't done anything yet. Alright. So you know the valve guides aren't going to be usable. Because kibble likes running undersized stems, so the valves are loose. See how loose they are?
Mm-hmm.
Racing fit. You want to be a racer?
Not on that particular part.
Oh, you want them tighter than that's what you're saying.
Oh yeah, that's moving.
That's loose?
Yeah.
Oh. It's all brand new.
Just because it's new don't mean it's right.
Low mileage head, wasn't it?
Gently ridden.
Not too bad on the wear. Yeah, you guys weren't worn out. Yeah, if you had stock valves, your guide would be good. But no, you have to go ahead and put custom stuff in there. Mix everything has to be changed.
Custom stuff, custom problems.
Yeah. All right. And you don't want me to chip this up, you said, right?
I would rather we not chip it up.
So how good is this powder coat?
I'd rather not even find out.
So you don't want me to do this to it?
It's actually pretty
Pretty good.
it's pretty tough.
Wasn't done down here. Can tell. All right, so we're gonna clean these up, change the guides. So this is Kibble White's beehive spring, I guess.
Yeah.
What's your sticker?
Sticker.
Look at that. Ooh, jeez. You gotta do all that stuff. Do you even know what any of that means?
Nope.
Good. How big of a can we putting in this?
I don't know.
So you're gonna go to 600 lift. Geez, that's a big spring. your keepers. What keepers, boss? What are these valves for? For your job?
Look, that's for another job.
That's for a different guy? These are for 2020 head. For a bigger motor than yours. Here's we're missing some parts. Does this kit come with everything?
No, I don't think. I don't believe that's actually a kit, sir. I think it's random, miscellaneous,
not the whole-
expensive pieces, missing other expensive pieces.
Performance Beehive spring kit.
Ooh, it is a kit.
It says kit right there. This fits a twin cam also, in case you didn't know. It's a nice sticker too.
I'll be keeping the sticker.
Important notice, it may be necessary to adjust stem protrusion in the head to achieve the installed heights. Installed heights of 1/860 through 1/870. 860 is stock, as I recall. Okay. Doesn't say anything about keepers.
We need keepers.
Do you have any keepers?
I do not. Do you have any keepers?
I know. I have crane keepers. I don't have stock keepers. I'm assuming if they didn't come with keepers that you're supposed to use stock keepers. It'd be nice if they had like in big print, use Harley Davidson keeper part number, blah, 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 blah. I do not see that listed anywhere. Kit includes 4 of that, 4 of that, 4 of that. We have 12 pieces here, so we're good. The only problem, they left out the 8 keepers you need. Minor setback. Failure to Mike. It's all Mike's fault.
We're coming for you, Mike.
Says right there. It shows nothing about a keeper. Okay, here we go. Retainer. It's pointed right at the keeper. I want to see the keeper. They don't even say what kind of keeper to use. This is a very high quality kit here. It tells you all of this important stuff you're supposed to do, and it fails to mention anything about keepers. So we're going to have to assume that it takes a stock keeper because they don't fail to tell you anything. Wonderful. That's a nice kit. I like kits like that. This is for 600 left. How much is this one for? Yeah, that one's for 600 left too.
Whoa. Size matters.
Yeah, this one probably works just as good as that, if not better. What does matter is weight. That's a lot heavier than that. Okay, so we have that combination of parts. Look what I got in my kit.
There we go.
Look what my kit comes with. My kit actually is a kit. It comes with keepers. It'll take me an hour to get in this bag. Let me figure that out. Oh, I figured it out. I read the instructions there. Okay, so weight matters. Which one's heavier? Oh, the kibble. So, big difference. Let's see, this one is seat pressure 150 at 1/800. 355 open at 1.2. This one's 175 seat pressure, 355 open. So same open pressure. So 355, 355. This one starts out higher than this one does. And this one installs at a lower number, install height, so it'll fit anything. So there you go. What's coil bind? They don't even give you a coil bind. See, this one gives you a coil bind number. Now, coil bind is where the coil, where actually springs go solid. Now, one thing you don't know about coil bind on beehive springs is you coil bind these things. That makes them not shake around. That's actually good. That's one advantage to them. You just you can't pack it solid. So you still gotta leave yourself 50. So that means that'd be 135. And you still got another 65 to go past that number. So you can run this thing at 640. You can put it at 640, can you, this thing? Even though they say it's that. And that's if you put it at the stock install height, which was what, 1,600? 1,800. Now if you jack that up a little bit higher, you can give you more install heights on the other side too. But this at 150 pounds seat pressure is more for an easier acting lobe, like a 640 S&S lobe, where it's kind of lazy. Not like a redshift. Yeah, redshift kind of semi in the middle. But those other ones, what those other ones, Black Panther fucking things, whatever they call them.
Oh, Woods can?
Woods, yeah, those pieces of crap. Those noisy things. They make good power, but they're hard out there. Those you better be running at least 175, if not higher on the seat. They're pretty aggressive on the open and closing rates, which means you need more spring tension. So for street application, this kit here is a lot better. For a hot rod cam, you're going to rev the piss out of. This will give you a little more installed heights. Same open pressure, so this is a lot heavier spring. This is better. Because whenever you lose weight, you gain RPM. And you also have less harmonics. So. One advantage of this is you got more wire to compress against. So this will, if it's equal for equal, will live longer than this spring will. Because you're working this one harder than this one. If everything's equal. Things aren't always equal. So, but you can see how much lighter these components are here. This stuff is what really matters. Now one advantage is I can take the stuff here and I can see if it fits. Because I have a set of keepers here now. Fits nice, like it's supposed to. Okay. Now let's take their collar. Take the manly keeper, which looks like a stock Harley keeper. Stay in. Didn't feel quite as tight, but it's good. So, if you use a manly keeper, it'll work. So my guess is we got to find some stock keepers for you, or you got to buy some high performance manly ones like this. Okay, we're going to figure this mess out. We'll be back. Okay, let's go down blouse and head out here. That's what it looks like after the blouse kit. And cleaned out. Most of the stuff out of the combustion. This is powder coat through here from Harley. These are black heads, they say. Harley powder coats everything in the machine. This would be before. Yeah. That's your before and after. A little different. More better. Trick is not to damage the powder coat. Here we go. Here we try. Goes in your window. All I got's right here to look at. Yeah.
Not seeing a whole lot there. Turn that light off to be able to see through glass better. Really not getting anything.
Well, you get more than you can. Not much. I can't see much either. air so I don't damage anything. See that? Turn the light back on now.
30.
Turn the light back on, you see better.
Oh, yeah.
And this that spot right there. Fired!
Minor.
I didn't do the inside here because I only didn't play around with it too much. Okay, now the guides are clean so I can knock the guides out. Alright, so I got to blow off the excess crap. Ladder over here. That air nozzle makes more noise than work. Might have more air pressure. Air volume here. Alright, we'll go back to work and finish the valve job.
Alright.
Alright, we're trying to figure out what to do on the valve stuff here. So these are 3 different valve guide installers. So it installs them at 3 different heights. So this one here is stock height. This one here is a little bit below stock, and this one's way above stock. So it depends on how far you want the guide to go into here. For high lift, we need a guide to sit deeper, or we got to shorten the guide in height. For reliability, you want the guide to stick in the port deeper, so that way you're not losing length when you move, because you need a clearance for the retainer here, clearance. You don't want this to hit your seal. So it comes up and hits the seal here. So that means you've got to cut the guide off or lower the guide. If you cut the guide off, then you get less reliability. If you move the guide in the same spot or drop it, you gain flow. If you bring it back up deeper into it, you lose flow a little bit. So it's a trade-off between flow and reliability. So this is a street motor, not a race motor, so it's more geared toward reliability than the other way. So we're leaning toward using this one, which basically pushes the guide into the head about 30 thou deeper than the stock one. This one here would stick it way up in the air about 60 thou less than stock. So it pulls the guide out of the head, which means you shorten the guide up. You wind up shortening the guide up probably about this much when you're done. You'll take a quarter, a couple hundred thou off the top of this guide, which is shorten your guide up. Lose reliability. So next thing is we're looking at our TD lift. That's how much both these valves are open. You don't want them hitting each other like that. That would be a problem. Catching that one. So what happens here is the exhaust is dumping out the flow and the intake comes and says hello and catches it. That's what you don't want to happen. That would be a bad thing. Because once you do that, then the piston says, hello, I'm here, and you bend both valves. So the intake does not open first, and the exhaust is closing, the intake's open, and that's what catches it. That's why usually the exhaust is, or the intake is the one that gets bent, because it's the one sticking up the most when the piston says hello. Boom, nails it. See how it shoved the exhaust closed when you hit it? The intake was still opening because the cam was still going this way. This one was going away. So that's why you always bend the intakes more than the exhaust. Plus they're weaker. Okay, so on our cam right here, our TD lift is right here. So it's 208 by 236. So basically that's 240 by 210. So we go over here and measure that and see what we got. Okay, now this is the exhaust. It should be about 210 right there. This is our intake. About right there. So they're not touching each other, but they're very friendly right now. Now the intake is a lot higher than the exhaust relative to the same angles. So you'd have to drop the intake probably 60, 70 thousandths to get it out of the way at all, before it even started to get out of the way. Whereas the exhaust, if you just close a little bit, you would gain pretty quickly. So if you move this one back 30 thou, you say you didn't really gain anything. Move the exhaust back 30 thousandths, you gained. See the gap in there? The gap's not in line this way, the gap's this way. But the gap's still a gap. So we're going to gain more by shortening the exhaust up than the intake. The intake you'd have to drop it, 80 thousandths to gain anything. Now you look at for the flow, you put the bigger valve in here to get flow. So if you sink this thing down in a big ass hole, you're losing your flow. If you sink the exhaust down, it's under pressure going out, so you're not really gaining, you're not losing that much. It's not ideal, but it's the lesser of two evils. So the intake will probably keep up a little bit higher in the air to gain that. Now the difference in the stall height right now is the intake's about 50 thou higher than it should be right now. But I like it sitting up pretty. It's better for more flow if it's up high like that. But the problem's our valve. The valve is a problem. So we're going to wind up sinking the intake about 30 thou maybe from where we're at right now when we do the valve job. The exhaust we're going to wind up probably sinking 50 thousandths, would be my guess. Not sure, we'll have to figure that out. But you definitely have to sink at least 30 minimum. So those are where I'm shooting at. So if I'm going to do those kind of numbers, that means the intake, we're not sinking it. That means we're not going to have an installed height here if the valve isn't coming up further. So that means we're going to push the guy deeper, otherwise we're going to lose room in here. So we're going to wind up pushing this one in deeper. So we're going to use this one here without the shim. This one over here, we're going the other direction. We'll get it longer. So we'll just use stock install height on this one. We should be fine. So we're going to take this washer off, which gains us a little bit. So this one here, 860 is stock. That's about 780. So that'll give us 80 thousandths clearance. 80 thou, which we're going to need. Probably pretty close to all of that. So that's when we're going to probably sink in the most. Now with a 560 lift, we might be able to get away with using this in there. Which one did I just measure with? That's basically about stock 850. It's hard to measure this here. Your thumb wants to move a little bit, so we're not getting true numbers here. That is stock. Let's measure with a real tool. What the hell? What are we measuring? Oh, we're measuring overall height. That's another problem. We're not sure exactly where the overall height's going to be. These numbers are not true because this is clearance. Can't measure it that way very accurately. So we got to add 370 to whatever our number is. Can you do that in your head?
No.
Oh. You sure? So if you rail, if you go 5 and you add 360, what do you get?
860.
Yeah, pretty close. 870, right in that area. So you can do it in your head. I knew you could do it. So we got 435 on this one. So we add in our 375 on top of that. Basically put us 10 thou over, so it'll be about 910. Or the other way, no. 810. Be about 810, which is 50 thou less than stock. This one is almost 600 right off the bat, so you add in another 375, 370 onto that. What do you get? 890 plus another 50 or 60 more, another 60 more. 950. That's the tall one. That's when you cut the guide off, way off. Alright, so I'm going to use this on the intake, this one on the exhaust. We're not going to use the racy one. I'm going to leave the shim out. And that's how we're going to do it. And we'll live with it. Because once I put the guides in there and fit them, I can't move the guide. It'll change the diameter. At least you shouldn't move the guide. Some people do. Okay, these are standard guides. These are for 1 over. Easy exhaust, use 1 over. Standard, get away with it. I mean, standard will work on the intake easily, most of the time. We'll see. See, before you do any work, you got to figure out what you're going to do. Then you know what to do. You know what you're going to do after the fact. This will help keep the guide from galling up a little bit coming out. Very little. If it wants to gall, it's going to gall. Okay, we don't need that. We need this. Don't need that. We need all this stuff though. Alright. One of these. No, one of these over here too. Not that one though. Yep, that's the one. Okay. So this is our pushing tool. That's your support. It holds it. If you're lucky, it comes out. Oh, it's getting tight. Gall up a little bit coming out. Not as much as I thought it was. See the little marks there? Starting to gall up a little bit. Wasn't as bad as I thought it was. See how it starts sticking right here a little bit.
That lube helps though, right?
Yeah, a little bit. Now if I pushed it back after I started doing it, re-looped and pushed it back, would have been easier, but it wasn't it wasn't bad enough to just stop. This one easy probably you'll have to. The exhausts like to weld themselves basically into the head. The metal gets too friendly with each other. It doesn't want to press out. Of course this one went right through, no problem. Got a decent press on it, as you can tell. And it's still galled the piss out of it, see?
Oh yeah, pretty good on that one.
Yeah, even though it didn't felt that bad, it did. That's why I put 1 over on exhaust usually. Okay. if you look at the guide holes look alright. A few marks in them, not too bad.
Yeah, not too shabby.
Now, I do
Considering.
my stuff cold because I don't like dealing with hot parts. There's lots of different ways of doing things. Do it how you like. But if you did heat it up, it'd go a little bit easier, but would be. My experience is if a guide wants to gall up, it galls up even worse when it's hot. That's my experience. Everybody has a different way of doing stuff. Pick the one you like. Okay, that's the intake. So what I like to do is get the guide started in the right direction. See how this will not fit in the hole? It's been beat on too many times. Want the guide to start straight. If you hit it too hard, it splits the guide. So we want to get it where it starts. Okay, this is what the intake. So we're going to use this big one on here. Let that not go. There it goes. Okay, this is the tool I use on the bottom. So the small one's for the exhaust. See, it doesn't work on the intake. Intake goes in there. So it's self-centering off the seat. Here's the exhaust. So the head can be free to go like that a little bit. It kind of self-centers. If you push sideways with the guide, it snaps the guide off. So you have to let the head self-center itself. It will help you if you let it. But if you don't, it'll break. Kind of self-center a little bit, go a little bit, loosen up, let it re-self-center, go a little bit, just go back and forth. You feel how much pressure it takes. If you don't like the pressure, you put tighter guide. It's all the way down. Break the bond of the goop. Okay, that guide's in there. Okay, now we're going to do the other one. Now, if you see a bunch of broached metal coming out of your hole or you're cracking the guide boss, that means you had too much press fit on it. That could be a problem.
That'd be a good indicator, huh?
That's a good indicator you screwed it up, yes. A lot of times they're cracked when you take them apart, though. Okay, this is a one over. Run the exhaust. Repeat process. This one, we're going to use this one on here. Exhaust flip over. Center up correctly. This guy is going really, really tight too. We could have definitely used a standard on this one. It's already going in, so it's too late to go back. Out. That was really, really tight. Yeah, that was definitely tight. Okay, so it's in there. So hopefully install height's where we're going to want them to be at. I did it right. That should be around 860. 870 right in that area, close enough. This one should be lower. It is about 820, about 50 thou lower. Alright, so it looks like about 880 is about stock install height, I guess. Alright, so that one's done. So if this one comes out just the same as the other exhaust, I'm putting a standard on the exhaust. That was way tight. Probably the first time the guys have been out of these heads. How many miles are on these motor, do you think?
Probably about 20 thou.
Yeah, that's why. Never been apart before. Got tight. Start squeaking, that's not a good sign. Looks good, but definitely didn't sound good. Oh, jeez.
Wow.
That's how the intake went back in on the other one, the one over.
Right.
That hard. See it galls at the end.
Yeah.
It makes it a little bit fatter. All right. What do you want, standard or one over on the exhaust?
Standard. That one was the tight one, right?
It was pretty tight going in last time, yeah.
Yeah.
If I don't like it, I'll pull it back out. But let's see. Okay, exhaust the short one. See how easy it goes in?
Mm-hmm.
So, yeah, it's kind of marginal. It's all right, but it's not real tight.
Yeah, it is pressing kind of easy, isn't it?
Well, it's not that easy. It's just not tight like the other one. I'm not going to worry about it falling out. It definitely wasn't as tight as one overhaul. Which you would expect it not to be, because you didn't beat it in as hard. So everybody likes it going in tight until it splits the head open. Then you don't like it, right?
That's right.
Of course, we all know when that point is, right?
Well, we know when it's gone there.
Now when it's pretty tight. All right. I'm good with that. Want the bigger exhaust got in there? Your call. I'm good with it, but if you want it in, I'll put it in.
I'm good with it.
Okay. So you have to put it in there with a jackhammer to make it work. Okay, so that part's done. Now we got to clean this up and then we'll do some honing. We'll be back. We're doing this, weren't we?
Yeah, I do believe we were.
Now we're on new valves now.
Yeah, we're trying to take the crusty crud off of old crappy ones. Now we're
Now we're doing the same thing on the new ones.
it's basically truing
honing the valve still.
Honing the valve.
See the show going on? The black, dark and shiny.
Yeah.
Dark is low spots, so that's all low. That's high. Low again, so I guess it fades away. They're real bright, that's shiny.
Yeah.
So when they ground the valve, they had chatter. So you're seeing the length chatter. The chatter was in the machine down the whole length of the machine when they ground it.
Right.
So we'll see how it comes back and goes. So it's pretty heavy right there. So that low spot.
Yeah, definitely.
So but even it's lateral. Sometimes you get a spiral effect going on.
So this just smooths it all out.
It makes it straight. It's not just smoothing, it makes it straight. It does make it smoother too. It makes it straight. Just like honing a hole, you're doing the hole on the outside of it. The black just makes it highlight, that's all that does. Don't run your knuckle in the vise over there, it hurts a little bit.
That's less than recommended.
Except mine's not hurting because I'm getting highlight. Some people think it's unsafe to have an open chuck over here. So. I don't know why you would think that would hurt. It would hit you. It hit right in there somewhere.
Don't try this at home, kids.
Just I didn't take it in to leave a mark, that's all. See that one same thing? I'm not worried about the up and down. That's the chuck's not made the chuck where I'm chucking at. See, these are not made precision grooves in the chuck here, jaw. But I'm using to hold the valve, so I don't care about the up and down part. I care about what the mark looks like. Fast strokes. Then you come back with a real slow one. Run it off the end. So this has a brass shoe right here, and then you got a stone over here. So the shoe is what keeps the valve straight, and the stone is what makes it even all around. So basically get this straight edge like this going down the length of the valve, so it takes out the kind of whoops in it a little bit. That's what it's supposed to do. And it does. It also makes it really smooth too. See, this one here didn't take off the block, so it kind of hides what you did. There's a slight color shift in the black though, you can see it, but not much. Measure the valve, this actually does take off a tenth or two of material. So you can see how the coating is thicker on the intakes of the valve.
Mm-hmm.
But if you feel it right now, it's really, really smooth. Because the hone finish is super, super fine. So you can hardly even see anything. It's like polishing it, but it's not. Polishing just makes something smooth. This makes it straight and smooth. Totally different. And there's your wasted valve material right there in honing oil.
Right. Speaking of things that are totally different, Tatro, I have a question here.
Bring up that stupid part again.
I couldn't help but notice I was over here and I observed something.
What's that?
That's what I was
You
asking.
want to know what this was?
Not exactly.
Oh, that's not what you wanted to know about?
No, something so close.
That's why it looks like a twin cam cylinder, I mean.
Yeah, it's very twin cam cylinder-esque.
That's my bracelet.
Yeah. What do we,
See, it fits almost up there.
it does. Any, would you like to shed a little light on what's going on with that project?
It's a tool.
Really? And what does it allow us to do?
It allows me to make stuff. That's for doing the cylinder case repairs on a twin cam.
Cylinder case repairs on the twin cam. Is that allowing us to just square it all up?
Yeah, it's, when you use the insert tool here, these are full of inserts in there you put in the cases when they pull the studs out of the cases.
Okay.
This is all the insert stuff down in here. And then somewhere around here is the tool. That was down with these screws. There it is.
Oh, I gotcha.
So this here goes down inside the case. Duh. This is your cylinder bolt pattern. Duh. And then you have a drill bush and it goes in here and then you remount your case right on center. So the stud goes vertical, straight, perpendicular like you want it to be, and on where it belongs.
Nice.
Because when you pull a stud out of the hole, there's nothing accurate to go by. It's all over the place. So this allows you to put them dead nuts on. So you want to put your new cylinder on, it fits right down. Now this here is the piece that got cut off.
Aha.
So when I cut the pieces all up, I squared them all up, made them nice pretty, so I might be able to use them down the road for something else. You never know. Maybe I need a stroker plate. Yeah, I got one.
There we go.
So I have 3 or 4 of those floating around here someplace. So it's just there. But this, the part I needed was this. So it cost me a set of cylinders, but yeah, I don't give a shit. It cost me 1 cylinder anyway. But anyway, that's what it's for.
Well, that's very cool. Thank you for letting me know and satisfying my curiosity.
So it's just more making tools. See, now that someone's finger screwed it, it's starting to corrode. Probably because I haven't used it in a few years. See, I used to get a bunch of these jobs and I quit getting the jobs because cases are so cheap, just buy new cases anymore. Plus the cases are so thin you can't really do this kind of work anymore. Pretty much throwaway motors. I might have mentioned that before, that twin cams are throwaway motors.
I think I've heard that once or twice
Yeah,
before.
there's a reason why I do that, because they're throwaway motors. It's cheaper to throw them away and get a new one than fix a piece of crap. They're not worth anything.
Gotcha.
No, they quit making them for 50 years, they might be worth something. For now, they're worthless. Oh, more hidden tools. Are you happy now?
Here we go.
You're all in the know now?
I'm all in the know.
You were dying to know that? Some commenter wanted to know what that was too, though, so you weren't the only one. There you go. One more of the hidden tools around here.
There we go.
I'm going to work on that, okay?
Sounds good.
We'll be back.
All right. Speaking of cool things around here. Oh, I gotta know what's going on with this. Got to know. And
Did you figure out what it is?
how about that? A little bit of this. Oh, there's all kinds of cool stuff going on in here.
We got crap everywhere.
Comments?
That's a before and after I welded it.
Wow. Before and after?
That was a set of takeoff brand new 110 cylinder heads.
Yeah.
Yeah.
That had a failure, I guess.
No, they were takeoffs.
Hmm.
Harley had all those compression release issues. They just give you a whole new head. This is one of those set of heads. These things probably only got 100 miles on them. Yeah, I made a couple changes. I took the tags off. So.
Oh, yeah.
But, there might have been a couple of modifications done to them. It's called playing around with valve angles and valve locations and combustion chamber depths. You know, so the old and the new is a little difference.
Figuring out what works.
See where the valve guide was, his new center line got moved to. Trying to figure out what I'm going to do. Come out the other end, see.
Oh, yeah.
Problem is they're too narrow when you get up here, because you still have to be with the rocker tip. The rocker still have to hit on the valve tip. So instead of figuring it out, I just do it and see what happens. Yeah. Instead of calculating it all on paper, I just make it. What the hell. So this here, all I gotta do is knock these out, these plugs, put 2 more plugs in there, try something different, put it back in there, do it again. No big deal. And we just see what's going on. So this one here is what it looks like before. You know, this is, after you figure out what you're going to do, then you cut it in this one. This one is obviously open slate.
Yeah.
doesn't appear to have any holes in it to speak of. So now S&S came out with those B3 heads and kind of eliminated that they sell for like $1,500. Why do you want to do all this work for nothing?
Gotcha.
But basically what I did was I changed the location of the parts. So the intake angle is roughly about the same location wise on the angle, but if you notice it sticks out a lot further.
Mm-hmm. Definitely.
What you don't notice is it's also been lowered quite a bit. See, my head's welded flat here, see?
Gotcha.
So the port, instead of being way up here, is actually way down here. So instead of the port making a tight turn right here,
It's all wide open. You can
this
get
one
it
goes way up underneath like this.
right, so it will move faster.
So if you look up in the head, you can see how it goes. It sweeps up into the valve like a real motor should be built, not like Harley does it.
Mm-hmm.
And you're using a rectangular shape because Harley doesn't have a lot of clearance on top. So if you can't make it big round all the way through, you have to go this direction. On the Chevy LS head, they went vertical because they have, they made the head this much taller.
Right.
Well, we don't have the luxury of that on a Harley because you got a frame in the way.
Right.
You got a very low height, so you have to go sideways. So that's what I did on that one. And like I said, I just moved it out. I could put a big plate on here and use a big oval manifold on it. Give her the round manifold, go to a big oval, which will flow better. Big improvement.
Very creative.
Then on the exhaust side, there was a few changes made over here on locations. So instead of following the same angle they did, which I never understood why they made a head port like this, because it's just stupid. So they have a port that's shaped like this. See where my finger's at?
Mm-hmm.
That's the valve guide right there. So the port should be coming like where my finger is. Get back up here and see further. Look up from this more vertical view. Okay, now the exhaust pipe comes at an angle like this. How do you make a turn like that? The exhaust doesn't make sharp turns. It wants to go this way. So when you do a hard shift like this, that kills flow. But they also did a hard shift up like this, because the pipe angle is also going uphill all of a sudden. So now you're making a sudden two-angle change, and the exhaust flow ain't liking it. So that's just stupid. So what I did on this one here is I limited that. So now if you look at my port, what's it doing?
Going straight in.
Goes straight in and also lowered quite a bit.
Right.
Because same deal, I welded up the bottom, dropped it way down. It's a lot thicker up here. Look how thin this one is over here. The ports are only this thick right here.
Mm-hmm.
Look how thick I am here. And this one's coming downhill a little bit. So it raised the port way up. So now you got, when you cut this all out, it'll be a nice sweeping around port. The problem is on the FLT chassis, touring chassis, the frame rail goes right in the way on the front on this head. So you don't have room. So, but what they do make is they have there's a company on car exhaust, they make a cast spigot with a radius in it. And it's a very, very tight radius, but it is a full radius. So you can't bend the pipe that radius, but you can cast it like that. So they use it for cars where you got real, well, like you try to put your Chevy V8 in your older car, it doesn't have room for it. The exhaust will tug it real tight and allow you to do it, but you still have good high flow. So I'm thinking you do the same thing on this. You can run a pre-bent pipe right here, it would clear the frame, but we have the nice straight angle into our head. So when I get time, I'll play around these a little bit and design up something I like. And I'll have one set of heads that'll be really, really nice. Or I'll have a template to have heads made. How do you want to do it? Instead of doing it the new way, which is all on a 3D. I work in metal, not 3D. So this is metal.
Nice.
Yeah. All right, kill the light this time. Get out of here.